Hi everyone, welcome to the GATE data science course. So this is lecture number 3 on counting, and in this lecture we will discuss permutation. Cool. So what is a permutation? Permutation is nothing. Permutation is permutation of a set is an arrangement of its members into a sequence or a linear order. Okay, as I told you in the last lecture, while discussing factorial also, then like permutation is nothing but in how many ways can you arrange objects. Okay. So by definition, if you want to permute n objects in n places, we already know the number of ways, it is n factorial, right? So permutation is what? Just arranging the members of a set into a sequence. Permutation without repetition. Okay, this is very important. We will discuss this a lot while solving questions, and read the question very carefully. Okay, whatever exam you're writing, like when aptitude questions come on counting, very carefully read it. Okay, I lost marks in GATE, I remember. Okay, but just because of this mistake, with repetition or without repetition. Okay, there is just one out which like you can miss very easily. Okay, so we will discuss it a lot. In a lot of problems I will like emphasize this point, like is it with repetition or without repetition. What do I mean by repetition? So generally these problems, like how will they go? You have to, let's say, arrange n objects in r places, but you have to see very carefully. By default, if nothing is mentioned, you can assume without repetition. Okay, if nothing is mentioned, it is like you cannot repeat. If repetition is allowed, they will mention it specifically. You cannot, you have to repeat, you can repeat as well. Okay, so by default it is without repetition, you cannot repeat objects. So for example, if you have n objects, 1 2, let's say you have 3 objects and you have to arrange them in 2 places. So by default you cannot repeat them, so you put one of the objects here, put one of the objects here. Okay, you cannot repeat them, you cannot use 4 twice. That is without repetition, you are not repeating the elements. Okay, so where we consider the number of possible ways of arranging n items into n places. Okay, so permutation without repetition is we have to arrange n items into n places. The factorial has a special application, we already saw it in last lecture, in defining the number of such permutations or arrangements in a set that does not include repetitions. There also we didn't repeat them. If I have to arrange n objects, I assumed that object is gone now. Now I have n-1 objects for n-1 places. Okay, so the interesting thing is, why are we learning permutation? We already know factorial, right? If we have to arrange n objects in r places, if you have to arrange n objects in r places, and r will always be less than equal to n. Why? Very simple, right? You cannot arrange 4 objects in 5 places, right? You can never arrange 4 objects in 5 places. One will remain empty. So the number of ways in which you can arrange n objects in r places, okay, the number of arrangements of r items out of n objects is considered to be a partial permutation, and it's written as NPR. That's how we write it. Okay, and we read it n permute r. So basically arranging r objects out of n objects. So let's try to derive it. Okay, again, like we have, let's first try to take an example and derive it. So let's take 5 objects. I have 5 objects, n is equal to 5, and let's say I have 3 places. Okay, very simple, like as we did in factorial. How many options do I have for the first place? Again, like anyways, you can always break all these proofs using the rule of sum and product. Most of them are applying rule of product, right? You have a task. What is your end task? Think of it like this: start and end. What is your end task? You have to arrange 5 objects in 3 places. So break it this way: fill the first place, then fill the second place, and then fill the third place. This is your task. Fill the first place. How many options do I have? I have 5 different options. I can put any number in the first place. I have 5 options for the first task. And rule of product. So, and now I have to fill the second place. For the second place, let's say for example I put 4 here. Okay. For the second place, how many options do I have? Again, it is without repetition, so I cannot repeat 4. So how many options do I have? 1, 2, 3 and 4. I have 4 options for the second place. And then how many options do I have for the third place? Let's say 3 went here. Now I have 3 options, 1, 2 and 5. I can put any element. Let's say I put 1 here. So I have 3 options for the third place. So this is the number of ways in which I can arrange, right? Very simple. So like coming to derivation again, like we can do the same thing for n objects in r places. So let's say now you have n objects. So for a generic proof, let's say we have r places. For the first place, I will have n options. For the second place, I will have n minus 1 options because one object is already gone. For the third place, I will have n minus 2 options. And this is defined to be NPR, right? I already told you. This is defined to be NPR, the number of ways in which I can arrange n objects in r places. And so on. Now think about it. How many options will we have for the rth place? Pause the video and try to think on your own. Okay? Okay, now I'm giving you answer. So how many options will I have for this place? So this is like a standard problem. You will see it most of the times when doing counting problems. You have some idea, you know for the first thing, like first occurrence what is happening. For the second time what is happening. You have to just extrapolate that and what will happen at the rth place. So like I have a trick to do that. I use that. So always try to create a map. Otherwise you will make a mistake. For first place you had n options, which was n minus 0. For the second place you had n minus 1 options. For the third place you had n minus 2 options. You see a pattern? For any ith place you will have n minus I minus 1 options, right? If this is I, you are doing n minus I minus 1. This is I minus 1. For 1 it is 0, for 2 it is 1, for 3 it is 2. So for rth place, how many options will you have? N minus r minus 1. Don't forget to add this bracket. Okay, don't write it this way, n minus r minus 1. This is wrong. Okay, so if you expand this bracket, it will come out to be n minus r plus 1. I hope you got it, right? So for the rth place, just extrapolate, you will have n minus r plus 1 options. Okay, spend this time. Okay, people tend to like they are like sometimes being too fast is also bad. So if you're being too fast, you will make this mistake. You will write n minus r minus 1. Okay, spend time and see, for 1 it is 0, for 2 it is 1. So it is n minus I minus 1 in brackets. So that way this is NPR, that's all. Okay, this is the proof. Now we can use factorials to simplify this. So what we can do is, we know that n factorial is the product of all the natural numbers from 1 to n. So why not complete it up to n? Let's try to complete it up to n. So the next number will be what? I'm multiplying some new numbers here and I'll divide by the same numbers. So I'll just divide by the same numbers. So what will be the next lower number? It will be n minus r. Right? Just subtract 1 from it. The next number will be n minus r. The next number will be n minus r minus 1. And so on up to 1. Okay? I just multiplied this thing in the numerator, so that I can have all the numbers up to 1 in the numerator, and I will divide by the same numbers in the denominator. N minus r minus 1 all the way up to 1. Now see this very easily, like you can see, the numerator is what? N factorial, and the denominator is what? N minus r factorial. Right? It is n minus r factorial by definition. So this is what NPR is. So this is the proof. NPR is n factorial upon n minus r factorial. Okay. Cool. So again, but generally I don't tend to use the formula. See, it will be always easier to solve NPR. So let's say you want to calculate. I'm giving you some tips and tricks. Okay, in exam. Let's say you want to calculate 7p2. Okay, if you always remember the formula, you will do it this way: 7 factorial upon 5 factorial and n factorial upon n minus r factorial. That will take like more time. So when you solve a lot of problems, what happens is you get to remember the proof. Okay, try to remember the trick, not the formula. Like why? Again, whenever you see 7p2, P means permute. Permute means arrange. Quickly, like get that in your brain. P means arrange. So you have to arrange 7 objects in 2 places. So the number of ways will be 7 into 6. For the first place, you will have 7 options. For the second place, you will have 6 options. Right? Don't do this. This will take more time. Okay, quickly you can calculate this. Right? Similarly, let's say you want to calculate 8p3. Permuting 8 objects in 3 places, 8 into 7 into 6. That's all. Just keep multiplying them 3 times, like whatever number of places you have. That will be quicker. This is actually the same thing as like the formula, but this will be quicker. Cool. Now let's try to see some problems. So this is the first problem. What is the number of 3-letter words with or without meaning which can be formed from the word party where repetition is not allowed? Here, like it is explicitly said that repetition is not allowed. But by default, if it is not mentioned, repetition is not allowed. Okay. So try to solve this. Then I'll do it. Okay. So we have party. See, the most important thing to note here is all 5 objects are different. This is also one thing you need to note. Okay, in all the proofs which I did so far for permutations, I assumed that objects are different. We are not arranging objects like this. 1, 1, 3, 4. No, you don't have 2 ones. Right now the objects were different. Here also the objects are different. You have 5 different objects. P, A, R, T, Y. All are different. In the later questions, you will see the objects will repeat and I'll tell you how to solve that. But for now, objects are different. You have to arrange 5 objects in three places. You have to find 3-letter words, right? So you have to just arrange 5 letters in 3 places. Very easy, 5p3. Again, like instead of going with the formula, just do it like this. Like you have 5 options, 4 options, 3 options, 60. Okay. So next question. Now we have some common words. So in how many ways can the word beaker be arranged? Okay. Now this is this gets slightly trickier, and we will solve this. So what happens is here they have not said how many places. So if they are not mentioning the number of places, by default you assume the same number of places as the object, right? So you have to arrange the entire word beaker. So there are 6 words, 6 letters, and you have to arrange this 6 letters in 6 places. So we have 6 places. Okay. Now what happens is, let's say like whatever we have learned so far, what will be your answer? It would have been 6 factorial, right? If like forget about like we have 2 e's right now. If we didn't had 2 same e's, the answer would have been 6 factorial. The number of ways in which we can arrange the 6 letters of the word beaker is 6 factorial, right? But there is a problem here. There are 2 e's. So what will happen? See this. So why is this a problem? Firstly, let me tell you that. So let's say we have 3 letters A, B, C. We know that there are 6 ways in which we can arrange it, right? 3 factorial. What are those? A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. Right? Now, consider this. Now let's say I make B as same as A. For now, let's assume B is also A. So if I apply the same formula, what are the words that I will be getting? I will be getting AAB, AAC, ACA, AAC. Right? I'm replacing every B with A only. So now I'm trying to arrange all the letters of the word AAC. Right? I'm replacing every B with A. So this is what the formula gives us. So this will become ACA. This will become CAA. This will become CAA. And this will become CAA. You see the problem, right? We are overcounting. We have AAC twice. We have ACA twice. We have CAA twice. The problem was what? We cannot apply the direct formula here because we have 2 A's. and the formula is for all distinct words, so you will have repetitions, right? So now how to solve this problem? So the trick is very easy. For now, assume that these two e's are different. Firstly, assume that these two e's are different. Let's call them E1 and E2. If I call them E1 and E2, then the number of ways will be 6 factorial. The number of ways in which I can arrange these 6 words, 6 letters in these 6 places will be 6 factorial. Now try to see what are we overcounting. Now E1 and E2 are same. So here what happened? Since A and B were same, every permutation was counted twice. Why? Because every B was A only. So when you swap B and A, that will be different permutation, but if you consider B and A same, that will be the same permutation. So you are actually counting every permutation twice. So why? Because the number of ways in which we can arrange these two among themselves. Here also the same thing. The number of ways in which we can arrange A and B among themselves is 2 factorial. The number of ways in which we can arrange E1 and E2 among themselves is 2 factorial. So every permutation will be counted 2 factorial times. That will be the repetition factor. So we have to divide this by 2 factorial. Similarly here, the actual number of ways was 3 factorial. But the number of ways in which we can arrange A and B among themselves when we have 2 A's is 2 factorial. So we have to divide by 2 factorial. So if I take a complicated example, let's say I have A, B. Okay, consider all of them different, then you will have 5 factorial ways. But now what is happening? The number of ways in which you can arrange only these 3 letters among themselves, keeping the other places same, will be 3 factorial, and all these 3 factorial places will have the same word. Think of it, right? Like let's say you have A1, A2, A3, A1, A2, A3, B1, B2. Keeping the position of everything same, if I just arrange these 3 among themselves, there will be 3 factorial or 6 ways. For example, A2, A1, A3, B1, B2, and you will have 6 ways, and all these 6 words will be same. So every permutation will be counted 3 factorial times. So you have to divide by 3 factorial. And same for B. The number of ways in which you can arrange B among themselves is 2 factorial. So you have to divide by that as well. This is the overcounting that we encountered and we solved it. So the number of ways in which we can arrange this will become this. So it's very simple, right? Just divide by the number of repetitions of every character. So here the answer will be 6 factorial by 2 factorial, which is 360. Okay? Okay, now more difficult problem. So again, pause the video and think about it. So the number of permutations of the word climate says that the vowels always occur together. Okay? Try to reduce the problem. Try to remember the rule of product. Try to reduce the problem and then solve it. So the number of permutations of the word climate says that vowels always occur together. First thing, there are 7 letters and all of them are different. So this is one good thing. Okay, and now how many vowels do we have? See, C is a consonant, L is a consonant, M is a consonant, T is a consonant, I is a vowel, A is a vowel, and E is a vowel. We have 4 consonants and we have 3 vowels. So if I forget about this statement, says that the vowels come together, then the number of permutations is easy, 7 factorial, right? We have 7 letters, we can arrange them in 7 factorial ways. But now there is a specific request ki the vowels must come together, okay? They like each other, okay? So now I, A, E will always come together. You cannot have a word. So you will have a word like C, L, I. In all possible permutations, you will have a word like this. But this is not allowed because I, A and E have to come together. And they have not said ki what is the order of them. They can come in any order, but they should be together. So observe this. C, L, M, T, I, A, E can be possible. And C, L, M, T, A, I, E is also possible. These are 2 different words. Here also vowels come together, here also vowels come together. Okay? So how to solve this? So try to break the problem again. There is a standard trick to solve this. Always see, when they say a certain group of people always come together, consider them as a group. Consider them as a single entity. consider them as a single entity. Let's say this is a different word. Okay, IAE is a different word now. Okay, you can name it anything. Let's say it is K. I have named it like randomly. Okay, so now what happens is I have made this group. This group comes together. Okay, like we should use group G. Okay, so this group always comes together. So in how many ways now can I arrange C, L, M, T and this group G? So again, like consider this as this task. You are starting. Your first task is to arrange C, L, M, T and G. Just arrange this. But here there will be some issues like this, right? Because IAE and AIE can again shuffle among themselves, right? So then I will do another task. Arrange letters in G among themselves, and that will be my end, right? So first I will just consider this IAE as a group G, arrange all the words, then I will see, like see I am undercounting. If I am just considering as a G, like the number of ways will be 5 factorial, right? 1, 2, 3, 4 and 5. G is one entity now. So this can be done in 5 factorial. But this is not my answer. Why? Because these two are different. And so so keeping everything constant, only the letters in G can be shuffled among themselves. And in G we have 3 words. In G we have 3 words. So we can arrange the letters in G in 3 factorial ways. So I have to do this and this. So the number of ways in which we can arrange it is 5 factorial times 3 factorial. Okay. Consider that particular group as G. So I can take one more example here. So let's take it here. So this, if you count, like it will come out to be 720. Let's say AAA. No, we don't want repetition. So let's say ABC and DEF. And let's say I tell you that AB will always come together and DEF will always come together. Okay, simple problem. Consider AB as a group G1, C is anyways alone, DEF consider it as another group G2. You have 3 tasks. Arrange first this 3. Arrange G1, C and G2. So this is your first task. Arrange G1, C, G2. Second task will be arrange all the elements among G1. And also you can arrange all the elements in G2. Right? So these 3 can be arranged in 3 factorial ways. All the elements in G1, there are 2 elements in G1. They can be arranged in 2 factorial ways. And all the elements in G2, there are 3 elements in G2. They can be arranged in 3 factorial ways. So for this example, the answer will be this. Okay. So, yep, this is one type of problem. Now adding everything, this is the most complicated problem that can come. The number of permutations of the word cheetah such that the vowels always come in odd places. So again, think about it, take some time, and so also observe, firstly observe the word. It contains 7 letters again, and it has 3 vowels and 4 consonants. Okay, so let's put all the consonants here, and we have 3 vowels. Okay, 4 consonants, 3 vowels, and the vowels are repeating also, so we will overcount. That's okay. Okay, now we know the trick of everything. Whatever we have learned so far, you can solve this problem. Okay, let's do that. So we have 7 places. Now the vowels always occur in odd places. Okay, they have a specific requirement. कि vowel can only come in this, or this place. Okay. So for now, let's assume these 2 are different. Whenever you have repetition, consider them different first. Solve the problem, and then you can always encounter the overcounting. You can just divide. So consider them different. Now these 3 vowels, E1, E2 and A, have to come in the odd places 1, 3, 5 and 7. Okay. So basically, what is the problem? You have to arrange these 3 words in these 4 places. They have to come in these 4 places. and the remaining four words, four letters can go anywhere, right? So like think about it. The number of ways in which, so basically it's like allocating. So for these three letters, E1, E2 and A, for these three letters you have to allot a number between 1, 3, 5 and 7. Okay, so for E1 you have four options. You can allot 1, 3, 5 or 7. E1 can go in any one of these four places, 1, 3, 5 or 7. For E2, how many options will you have? Let's say 1 is gone, so you will have 3 options. And for the final A, how many options will you have? The remaining 2 options. So it's like allocating these 4 positions to these 3 words. We anyways knew it. It is 4p3. We anyways knew it. Okay, right? So basically allocating 4 positions to 3 characters. 4p3 is the number of ways. So this is my first task. First task T1 was just arrange all the vowels in the odd places. We have done that. This is the number of ways. Now what is the second task? Second task is arrange the consonants. So this was arranging vowels. Next is arranging consonants. Once we have arranged the vowels, the problem became simpler. How? Now we have 4 consonant and remaining 4 places. 4 consonant and remaining 4 places, whatever, they can be anything. So to arrange 4 consonant in 4 places, 4p4 or 4 factorial, you can write anything. Right? 4 consonant, 4 places, 4 factorial. And yeah, that's all. This is our end. Right now I have considered E1 and E2 to be different. So this is the number of ways in which I can arrange the letters of the word cheetah. Considering both the E is different, E1 and E2, it will be 4p3 into 4 factorial. Okay, but now again we are overcounting. What are we overcounting? E1 and E2 are not different, they are same. So in every such permutation in which E1 and E2 are different, we are counting it twice, because E1 and E2 can be arranged among themselves in 2 factorial ways. So yeah, we have to divide this number by 2 factorial. We have to divide this number by 2 factorial because E1 and E2 are same. We are overcounting every permutation twice because E1 and E2 can be rearranged among themselves in 2 factorial ways. So this is our answer. This will be what? 4p3 is 4 into 3 into 2 and 4 factorial is 4 into 3 into 2 into 1 upon 2. Okay. So you can just calculate it. It will come out to be 288. So this was the number of permutations. So this is like having everything what we have discussed so far. We have 7 letters. There were repetition and the vowels had to go in certain places. So it included permutation, the rule of product, and the concept of overcounting and undercounting. So that's how you do it. Okay, we will be doing more such problems. So whenever I have live sessions, when I do problem solving sessions, I'll come up with more such problems and we will solve them live. But for now, yeah, this is about permutations. Thank you.